Okay, let's talk about data. We are absolutely swimming in numbers and statistics every single day. But what do they really mean? Today, we're going to arm you with a few simple but super powerful tools to help you find the real story that's hiding in the numbers. And it all starts with one surprisingly tricky little word.
Right, that tricky word is average. When you hear it, what do you picture? Because as we're about to see, that one word can be incredibly misleading. You know, if someone only gives you the average of something, you got to wonder, are they really giving you the full picture?
To really see what I'm talking about, let's dig into an example. Let's say we want to answer what seems like a pretty simple question. What's the typical starting salary for someone who just graduated with a degree in basket weaving? Seems easy enough, right? So here's our data. We've got the actual starting salaries for 9 recent grads. And just glancing at it, you can see, a couple in the 20s, some in the 30s and 40s. But let's do the math that most of us would do to find the average and just see what number we get. So you add them all up, you divide by 9, and you get $83,733. Whoa. I mean, honestly, that's a fantastic starting salary in pretty much any field. It looks like those basket weaving majors are doing pretty well for themselves. But wait a minute. Does that number really feel like it represents a typical person on that list? Let's look again. See, most of the salaries are kind of hanging out between $15,000 and $50,000. But then you see it. One massive salary of $487,000. That one person is dragging the whole average way, way up and giving us a totally warped idea of reality. Okay, so to solve this kind of puzzle, we need better tools. Statisticians have this fancy term for them. They call them measures of central tendency. But really, it's just a simple idea. It's about finding different ways to describe what a typical data point really looks like. The way I like to think about it is like we have 3 different detectives on the case, and each one has a totally unique way of investigating our data. We've got the mean, the median, and the mode, and each one is going to give us a different clue about where the real center of our data is.
So first up is detective mean. Now, this is the one you probably already know. It's what we all learn in school as the average. You just add up all the numbers and divide by how many you have. It's the exact calculation that gave us that really impressive, but, really misleading $83,000 salary.
But here's the mean's big weakness. Its fatal flaw, really. It gets pushed around super easily by extreme values, what we call outliers. Remember that one grad who's making almost $500,000? Well, that's our outlier, and it's single-handedly pulling the mean way up, making it a pretty poor representation of the group as a whole. All right, so if the mean is so easily fooled, let's bring in our second detective, the median. The median's whole approach is different. It couldn't care less about crazy high or low numbers. All it wants to do is find the one value that's sitting smack dab in the middle. And to find it, it's easy. We just line up all 9 salaries in order, from the lowest to the highest. The one right in the middle, yep, the 5th one on our list, is $37,300. Now that number, that feels a lot more real, doesn't it? It basically just ignores that one huge outlier. And that brings us to our final detective, the mode. The modes method is the simplest of all. It's just a popularity contest. It looks for the one value that shows up more often than any other. So if we look at our list, the salary of $27,000 shows up twice, and every other salary is only there once. So boom, our mode is 27,000. This is actually super useful when you want to know the most common result. I mean, think about it. Predicting the average score of a football game might give you 15.3 points, which is impossible. But knowing the most frequent score, now that's actually useful. Okay, quick recap of our 3 detectives. The mean, it's the classic average, but it's really sensitive to outliers. The median, it's the true middle value, and it's great at ignoring those extremes. And the mode, it just tells you what's most popular. The big takeaway here is that you can't just rely on one. Each of them tells you a different, important part of the story. But, knowing the center isn't always enough. Finding that typical number is great, but it tells us absolutely nothing about how spread out or how tightly clustered together the rest of the numbers are. There's another piece to this puzzle. To get what I mean, let's think about a new little mystery. What if you had 2 different groups of numbers, and they had the exact same center, but just looking at them, they were totally different? How in the world would you describe that difference with a number? Check this out. Here are 2 sets of data. Believe it or not, they both have a mean of 5 and a median of 5. But, you can see with your own eyes, they are completely different animals. Data set A is all spread out, from 1 to 9.
Data set B is super tightly packed, right there around the middle. To really capture this idea of spread, we need a new tool, and that tool is called the standard deviation. It's simply a measure of how spread out the numbers are. The easiest way to think about it is it's kind of like the average distance that any one number is from the mean. So a small number means everything is clustered together, and a big number means it's all spread out.
Now let's look at our two data sets again, but this time with our new tool. And suddenly, the difference is crystal clear. Dataset A, the really spread out one, has a high standard deviation, almost 2.6. But dataset B, the one that's all bunched up, has a super low standard deviation of less than 1. See, this one number finally tells the story that the mean and median just couldn't.
So, there we have it. We've got our detectives for finding the center, the mean, median, and mode. And we've got our tool for measuring the spread, the standard deviation. So the big question is, how do we actually use all this stuff together to tell an honest, complete story with data?
Well, the most important lesson, I think, is this. There's no such thing as a single best statistic. The mean isn't inherently better than the median. They're just different. The right tool to use always depends on what your data looks like and what question you're actually trying to answer. So what's the big rule to remember? Well, the folks at the Purdue Online Writing Lab have a fantastic rule of thumb for this. To tell the whole story with your data, you should always give people two things. At least one number that describes the center, like the mean or the median, and at least one number that describes the spread, like the standard deviation. A mean without a standard deviation, that's only giving people half the story.
So now you have the tools. The next time you see a headline or read a report and it talks about an average price or an average salary, you can think like a detective. You can ask, okay, but what kind of average is that? And maybe even more importantly, and what's the spread? Just asking those two simple questions is the first and most important step to truly making sense of all the data around you.